Electric motors are devices that are widely used in electronic goods. Then how do electric motors work? We will discuss that. Electric motors work using electromagnetic forces. The electromagnetic force is an invisible force that stores energy. If we put two magnets together, one of the magnets will either approach or move away. The direction of this movement depends on the direction of the magnetic field. In fact, the energy in the electromagnetic force can also be directed into rotational motion. This is what makes the rotational motion formed in an electric motor. But how? Check the following animation. There are two magnets placed in a row. Then, in the middle of the magnets I put a wire. If an electric current flows through the wire, then the wire will move. This is match with Flemming left-hand rule. This rule states where the wire move in the magnetic field. The second finger shows the direction of the magnetic field, the forefinger shows the direction of the current, while the thumb shows the movement of the wire. From this rule, we know that the wire will move up. This can be explained because when an electric current flows through a wire, a magnetic field is formed around the wire. In fact, this wire is in a magnetic field generated by a permanent magnet. This causes a collision in the upper area of the wire. On the other hand, there is a buildup of magnetic fields under the wire. The colliding magnetic field will dissipate the energy in the area, while at the bottom the energy is multiplied. It makes the energy in the bottom of wire is bigger. As a result, the wire pushes upward. However, this principle only applies to DC electric motors that have direct current flow. While for AC currents, the principle is different. Then how to make the rotation motion? The wire will be looped like this, so that the electric currents on the two sides of the wire are opposite. It makes the wire motion also opposite. Then, the electric current is connected using two brushes. When this brush hits the wire will move around. To make the wire loop more stable, we need to add some wire. Now the rotation is more stable. Now back to the electric motor. In an electric motor, the wire is made of copper. However, in order to maximize the magnetic field, the wire is wound around the iron core and the amount of wire wound is also thick. This component is called the rotor. For static magnetic fields, it can be generated from permanent magnets for small DC motors. But to get a bigger output, a static magnetic field is created from the coil. This component is called the stator coil. Stator coil produce static magnetic field from electricity. To do it, there are two coil rounded the iron core. And the current is in line. It make the magnetic field created with same direction. In this position, when the electric current flows, magnetism occurs in the stator and rotor. As a result, the rotor rotates. So, the conclusion is that an electric motor can convert electrical energy into physical energy through a magnetic field. This means that electrical energy is not directly converted into physical energy, but electrical energy is used to create magnetism. The magnetism is the thing what makes the rotor spin. Subscribe to our channel and stay tuned for the next videos.